Welcome to lesson 4.6a. This is where we're going to talk about the graphs of tangent and cotangent of x. So we're going to start off with tangent. So just quickly to graph our basic graph of tangent of x that you need to know by heart, we're going to understand why it is the shape it is because it's not a wave like sine and cosine. So I'm going to mark the x-axis with a few labels first. So I'll say 2 boxes is pi over 2. So 4 boxes is pi. And we'll put a negative pi over 2 here, and we'll put negative pi here, and if we need to do more later, we can. But so what we understand is pi is 4 boxes long. Alrighty. So let's use our understanding that the tangent of x is the sine of x divided by the cosine of x. And if we're looking at the unit circle, then tangent, sine over cosine, means y over x. So when we go to read tangent off the circle, we'll take our y coordinate divided by our x coordinate. So at 0 radians, y over x is 0 over 1, which is 0. Make sure that you don't misunderstand that, think that the 0 is on the bottom. So 0 on top is 0. All right, I'm going to hit more than just north, south, east, and west. I'm going to use pi over 4 here because that would be our first box. Half of pi over 2 would be pi over 4. So root 2 over 2 divided by root 2 over 2 is going to be 1. Any number divided by itself is 1. So there's a point on the graph. And then we get up here to pi over 2, and y over x is 1 over 0, which is undefined. All right, so I'm going to draw an asymptote. If you recall, asymptotes are lines that are invisible in the graph. And so we draw them dotted because we would like to see them, but we would like to acknowledge that they're not part of the graph. So we have this weird thing that happens in this graph that didn't happen in sine or cosine. So this actually goes up and heads toward the asymptote, but doesn't touch it. Okay, remember a curve approaches an asymptote but doesn't touch it. So this general trend from left to right was upward. So when we draw that in, we'll head toward the asymptote. All right, I want to kind of back up and do some to the left because I kind of hit a brick wall here. So I'll do, and I'm going to treat this like negative pi over 4 because we're going to go backwards around the unit circle. And so when I do y over x down here, negative root 2 over 2 divided by positive root 2 over 2 is going to be negative 1. So I'm going to graph a dot, pardon for the background noise, I'm going to graph a dot at negative 1. Well, I really wanted red. Let's try that again. And then I'm going to go down here to, not 3 pi over 2, I'm going to call it negative pi over 2 because I'm going backwards. And that's going to be negative 1 over 0, which is also undefined. So if I go the other direction, I kind of hit a dead end. But this dead end is legitimate. Let me do it purple like I did the other one. We've completed one whole cycle of this graph. And I'll show you. I'll keep doing a little bit more so you'll see that this pattern is repeated. If I go the positive direction, after pi over 2, I'll do 3 pi over 4, and that's going to be root 2 over 2 divided by negative root 2 over 2, which is negative 1. So that'll give me a dot at negative 1. Trying to keep the graph red and the asymptotes purple. So at 3 pi fourths, so if each box is pi over 4, so 1 pi over 4, 2 pi over 4, 3 pi over 4, negative 1. And then down here, pi is 0 over negative 1, or just 0. So at pi, I hit 0. And if I keep going around this direction, 5 pi over 4 gives me negative root 2 over 2 divided by itself. Well, anything divided by itself is 1. So I see this pattern beginning to repeat. So watch what I had. 3 dots in a row going up and an asymptote. Let's see if this proves to be an asymptote. This is going to be, since this is 3 pi over 2, this is going to be 2 pi. So at 2 pi, no, wait a minute, 3 pi over 2, I got, oh, I did, okay, 5 pi over 4 was this one, 1, and then I've got to do 3 pi over 2. So 3 pi over 2 is going to be negative 1 over 0, which is undefined. So yes, I have an asymptote. Sorry, I lost my place. So now we've seen this pattern happen twice, and the truth is this pattern repeats forever, to the left forever and to the right forever. And what we have left to do is understand the curve. So when you draw this curve in, I want you to start from the middle and go through, make it a curve, go through this dot, and then head toward the asymptote, but don't actually cross it. And then when you draw the piece to the right, I start from the middle, I go through this dot, and then I head toward the asymptote, but don't actually cross it. So this is what our tangent curve looks like. So practice drawing it one more time. Start from the middle and fall to the left, head toward the asymptote. Start from the middle and rise to the right and head toward the asymptote. So this is what our curve looks like. Now, I want to call some attention to you. There are dots at 1 and -1 that are part of the pattern, and you only see 3 dots in the pattern. So this pattern is not 5 dots, but it is not dots, 2 asymptotes and 3 dots. So what we have is asymptote, dot, 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 asymptote, and we know the x-axis goes through this dot right here. So instead of having a 5-dot pattern, it's 3 dots and 2 asymptotes, but they're always going to be in this pattern until we start messing with the equation. So we are going to move to equations that we stretch or shrink with a number multiplied by the function, and then we will have a bx plus c where we make the period wider or shorter like we did with sine and cosine, and a c over b thing where we shift the curve left and right. So we do have to review those ideas just like we did with sine and cosine, but you have to know what the fundamental curve looks like in order to do that. All right. I do want to talk about A first. Let me slip over to a page where you can have some notes here. So let me fill in some blanks here, and I'm going to do a little screenshot of this and carry it over to this page so you can have this to look at while I'm talking. Okay, I'll just put it there. Get my arrow back. Okay. That's going to bug everybody. I think you'll live, though. We are looking at our original curve. And I want you to help fill in some of these questions from this picture. The asymptotes are where tangent is undefined. So the curve heads off to infinity, but it never crosses this line. So tangent doesn't actually exist where those dotted lines are because it's undefined. All right, from the x-intercepts, notice we cross the x-axis here and here. From these x-intercepts, we're going to rise to the right when we draw it to the right, and when we draw it to the left, we're going to fall. So fall to the left. All right, now amplitude. This is not a wave, so technically it doesn't have a wave height. But when we multiply tangent times something, it is going to change the shape of this curve, a stretch or a shrink. So we're going to say the original tangent curve that you're looking at up there, the multiplier out front is 1. A is 1, although I'm not going to call it amplitude here. I might slip and call it amplitude, and I beg that you would forgive me if I do that. But it is indicating the height of what I call the shoulders of the curve. So let me do this in green so it sticks out. The shoulders of the curve off the x-axis. That's a height of 1. This is a drop of 1. So that's where what we think of as amplitude with waves comes in. It's the shoulder height. Okay, so I'm going to say shoulder height. And we'll talk about how that changes when you change the value of A, shoulder height. Okay, the period, if you'll notice, goes from negative pi over 2 to pi over 2. So each half of it is half of pi. So half of pi plus half of pi equals 1 pi. So the period is just 1 pi, not 2 pi like sine and cosine was. And in other graphs then, instead of, if we mess with B, and it changes the period, instead of being 2 pi over b like it is for sine and cosine, it'll be regular pi over b, just 1 pi. That will give us the period of a new tangent function that's been altered. All right, so in order to graph one that does have changes in B and C, to account for phase shift, all right, so under phase shift, my advice to you is always draw the asymptotes first. And so figuring out where the asymptotes go is, here's a little trick, okay? Bx plus c are the numbers that affect phase shift. Remember c over b? All right, but I'm going to make it easier. Well, this curve is a little bit more complex than a wave. So I'm going to give you a trick, and we're not going to worry about c over b on this one. And we're going to take our known asymptotes at pi over 2 and negative pi over 2 and say, well, this shifts it around from there. So if pi over 2 is our starting point for plain old tangent of x, then we can figure out the shift in the x direction by solving this little equation. And only when I do it for a curve that has values for b and c will you see what I mean by this. And then we can use the width of the period to find the other one. Or we can also do another little equation, bx plus c equals negative pi over 2, and solve for x to get the other asymptote on the first period that we graph. So you won't understand that till you see it in action. But let's keep going notes-wise. So we'll solve for x. That's a comment pertaining to this up here. So finally, the x-intercepts are in the middle of the period every time. So halfway between the asymptotes, middle of the asymptotes, you'll find where the graph crosses asymptotes, asymptotes. Halfway between the asymptotes, you'll find where the graph crosses the x-axis. And then on the quarter points, so if this is the beginning and this is the end and this is the middle, right here is the first quarter point, and over here is the third quarter point. And it says find the points 1/4 and 3/4 between the asymptotes, y values of negative a and a. So in the case of my main parent function, a was just 1, so we saw these points happen at -1 and +1. All right, that's good for the notes. Let's graph a particular function now and put all this to work. I'm going to say y equals 2 tangent, which is going to stretch it, and then do 2x plus pi. Okay, so I told you first draw asymptotes. Okay, so this is this little part right down here that is kind of giving you steps. So asymptotes, so we're going to take the bx plus c part right here, 2x plus pi, set it equal to pi over 2 because that's where our original asymptote is in the original graph. We're going to solve this for x and we're going to see where the asymptote moved to. So I'm going to subtract pi. So I'm going to have 2x equals, now pi over 2 minus pi. Well, how am I going to do that? Remember, I can write this as a fraction. Let me do it in the margin over here. Pi over 2 minus, well, I have to write pi as 2 pi over 2. See how the 2's would cancel and it really is just pi, but now I have a common denominator. So this is negative pi over 2. So 1/2 minus 1 is negative 1/2. Negative pi over 2. And then when I divide by 2, okay, let me describe it as something other than dividing by 2. If I multiply by 1/2, then these cancel. All right, so I got to multiply this side by 1/2. And so when these cancel, I have x, and when I multiply these, I've got negative pi times 1, which is negative pi, over 2 times 2, which is 4. So my asymptote went from positive pi over 2 to negative pi over 4. So I'm going to draw that in. If I make one box pi over 4, then 2 boxes is pi over 2, and 4 boxes is pi. All right, do that same pattern to the left. 2 boxes is negative pi over 2, 4 boxes is negative pi. Now I've got my axes labeled, or axis labeled. I'm going to use 1, 2, 3 for the y-axis, so for one box is 1, so I don't have to label that. But I'm going to draw an asymptote at negative pi over 4. Okay, now to find my other asymptote, I'm going to do this in red down here so it sticks out. I'll take my 2x plus pi and set it equal to negative pi over 2, since that was my other original asymptote. Can you see how the first asymptote went from pi over 2 and it got shifted left and wound up at negative pi over 4? Let's solve this one now. Let's subtract pi off. 2x is negative 1/2 pi minus pi. So negative 1/2 pi minus 2/2 pi. 2 over 2 is our common denominator, is minus 3/2 pi. So that's going to put me here. Now, 2 things happened when I did that. Notice how they're closer together than they were. All right, if I do these in purple, you can probably see them better. So the asymptotes are moved, and they're closer together. So let's see if this makes sense. If we wanted to find the period, pi over b in this case is 2. So pi over 2 is the new period, and if you'll notice, pi over 2 is 2 boxes, and now it's 2 period, or the period is 2 boxes instead of 4 boxes. So that makes sense. So this kind of takes care of the period as well. And if I want to draw 2 of these, then I need to take another period to the right, 2 boxes for a period, so another 2 boxes. Draw another asymptote. And now I'm going to do my 3-dot pattern, okay? So once I found the asymptotes, I can find the halfway between the asymptotes and draw a dot there. All right, and then the quarter points, halfway between my asymptote and the green dot, I'm going to fall to the left, and I'm going to go the distance of what we would have called the amplitude. Now it's the shoulder height. So halfway over, I go down 2, and then halfway between the middle and the end, I go up 2, and I get this really skinny curve. Looks like this. It barely looks curved at all. Because when we stretch it taller and make it skinnier, it starts to look kind of like a straight line, but it'll never be perfectly straight. So there's 2 periods of my new function. This is going to take some practice. I'm going to do one more for my tangent video. So let's do, I need a graph paper. So I need my pointer to pick up a piece of graph paper. Okay, and I'm going to do my axes. And there, okay. So the curve I would like to do this time is y equals -3 tangent of 1/2 x minus pi over 2. Okay, so let's do a, not really amplitude, but a is 3, and notice it's negative, so it's been flipped. So instead of going like this, we're going to go up to the left and down to the right. That's a flip. So there's our flip. So we're not going to graph it like this time. The period is pi over b, and b is 1/2. So pi over 1/2 is pi times 2 over 1, which is 2 pi. And that's our period. So that's how far apart our asymptotes are. And then we've got to solve our little equations. Bx plus c is pi over 2, and bx plus c is negative pi over 2 to find our first set of asymptotes. So b is here, c is here, so bx plus c equals pi over 2, and solve this. So I've got to add pi over 2 to both sides. So 1/2 x, this is 0, pi over 2 plus pi over 2, 1/2 plus 1/2 is 1 pi. And then I'm going to multiply both sides by 2 to get rid of the fraction. So 2 times 1/2 cancels, x is 2 pi. So I'm going to put an asymptote at 2 pi. Now I'm going to solve for the other asymptote, bx plus c, from the equation and set it equal to negative pi over 2. And then I'm going to add pi over 2 to both sides. You'll notice the steps to solve this are the same the second time as they are the first. That's 0. 1/2 x equals negative pi over 2 plus pi over 2. That would be 0. And multiply both sides by 2 to isolate x. X is 0. So my asymptotes are going to be at 0 and 2 pi. So let's draw those in. 0. Always a dotted line. Now I'm going to make 2 pi 4 boxes. So there's the end of the period. And if I want to do 2 periods, I've got to do 8 boxes. I can go either direction. 4 more boxes to -2 pi. And then I'm going to do my 3 dots in the middle. Okay, so 4 boxes wide. Dot goes in the middle. And then halfway between the asymptote and the dot is here. And my shoulder is 3. And I've got to go up to the left. So over and up 3. right and down 3, and there's one tangent curve. And then I draw the same pattern over here and go down right, up left because it's flipped, and that was terrible. All right, go through the dot, head toward the asymptote, and there's 2 periods of my transformed tangent curve. Thanks for listening.